Hello and welcome to this lesson on the reactions between metals and oxygen. In today's lesson, we will recognize the products of the reaction between a metal and oxygen and understand the concept of oxidation in this context. We will also recognize how different metals react with oxygen based on their reactivities. Let's delve into the main concepts of today's lesson about the reactions between metals and oxygen. When a metal reacts with oxygen, it forms a metal oxide as the product. A metal oxide is a compound that consists of metal atoms bonded to oxygen atoms. For instance, when iron reacts with oxygen, it forms iron oxide, which you might know as rust. This is a common example of a metal oxide that you may have seen in everyday life. In more precise terms, a metal oxide is composed of metal cations, positively charged metal ions, and oxygen anions, negatively charged oxygen ions. These charged particles are held together by ionic bonds, forming the metal oxide compound. It's essential to understand the chemical reaction that takes place during this process. When a metal reacts with oxygen, the metal undergoes oxidation. Oxidation, in this context, means that the metal is gaining oxygen. Let's look at an example to make this clearer. Consider the reaction between calcium and oxygen. When calcium reacts with oxygen, it forms calcium oxide. The balanced chemical equation for this reaction is as follows: 2Ca plus O2, which becomes 2CaO. Breaking this down, we see that two atoms of calcium react with one molecule of oxygen gas to produce 2 units of calcium oxide, which looks like this. Let's now examine how the reactivity series links with oxidation of metals. Metals towards the more reactive end of the reactivity series, such as potassium, burn in oxygen. Metals that are less reactive, such as copper, will form a thin layer of their oxide on the outside, but will not burn. The least reactive metals, such as gold, will not react with oxygen at all. That is why gold doesn't rust. Using those observations, you can qualitatively tell whether a metal is highly reactive, moderately reactive, or unreactive. This concept of metals reacting with oxygen to form metal oxides is crucial in understanding many chemical processes, both in nature and in industrial applications. Let's dive into some GCSE level questions to apply our understanding of the reactions between metals and oxygen, focusing on the formation of metal oxides and the concept of oxidation. Write the balanced chemical equation for the reaction between magnesium and oxygen, and describe what happens during this reaction. When magnesium reacts with oxygen, it forms magnesium oxide, or MgO. The balanced chemical equation for this reaction is as follows: 2Mg plus O2 gives 2MgO. 2 atoms of magnesium react with 1 molecule of oxygen to form 2 units of magnesium oxide. In this reaction, magnesium undergoes oxidation by gaining oxygen. Let's look at the formation of aluminium oxide. Write the balanced chemical equation for the reaction between aluminium and oxygen and describe the oxidation process. When aluminium reacts with oxygen, it forms aluminium oxide. The balanced chemical equation for this reaction is as follows: 4Al plus 3O2 gives 2Al, 2O3. 4 atoms of aluminium react with 3 molecules of oxygen to produce 2 units of aluminium oxide. Aluminium atoms undergo oxidation by gaining oxygen atoms. By working through these examples, we've learned how to identify the products of reactions between metals and oxygen, write balanced chemical equations, and understand the oxidation process in terms of gaining oxygen. This practice will help you tackle similar questions effectively in your GCSE exams. In today's lesson, we delved into the reactions between metals and oxygen. We learned that when a metal reacts with oxygen, it forms a metal oxide. We also explored the concept of oxidation in this context, understanding that oxidation involves the gain of oxygen by the metal. Finally, we explored how different metals react with oxygen based on their reactivity. Overall, this lesson enhanced our comprehension of how metals interact with oxygen, the nature of metal oxides, and the fundamental principles of oxidation.